Question 4 is about bonding, and the question is asking you first of all to complete the table. So the table has got potassium, potassium bromide and water, and we need to indicate that potassium bromide is a giant ionic lattice. We know this because it's a metal and a non-metal. It's not enough to say ionic, it must be a giant ionic lattice. And then we have water, which is a simple covalent molecular lattice. Simple covalent lattice or simple molecular lattice would be fine, but good practice use both terms when you are looking at simple molecules. We're then asked to explain why there is a difference in melting points of these three substances. In your answer, refer to particles, forces between them, and the relative strength of the forces. So it's giving us three things that we need to do, or three things that we need to talk about. In answering this question, I would begin with a few things to recall. We know that potassium is metallic bonding, potassium bromide is ionic, and water is covalent. And state that again in the essay question. Metallic bonding is the electrostatic attraction between positive ions and negative electrons. Ionic bonding is the electrostatic attraction between positive ions and negative ions. And covalent bonding, when we are looking at melting a covalent substance, it is not the bonds between the oxygens and the hydrogens that we are breaking. It's the intermolecular forces of attraction between this water molecule and the next water molecule. So in this case, what we would actually be breaking is not the simple covalent structure itself, but the intermolecular forces between them, which in this case are hydrogen bonds because we have oxygens and hydrogens present. Hydrogen bonds are the strongest type of intermolecular force that we study, and we need to indicate that they are between water molecules. If you omit the fact that they are between water molecules, you will lose a mark. These are the things also that are broken on melting, as I stated, not the bonds between the oxygens and the hydrogens. So we just need in this question to remember what melting actually means. Now, all of that will get you 5 marks, and to get your 6th mark you need to reference the order, which is that ionic is the strongest in the lattice because it has fully positive and fully negative ions. Metallic is the next strongest because it has fully positive ions and it has negative electrons. Hydrogen bonding is the weakest and therefore easiest to break, and that is because it is an intermolecular force between the covalent molecules rather than a more significant force. The next part of question 4 goes on to give us a calculation about potassium reacting with water, so linking into the previous part of the question. We're given some information and some numbers on the amount of potassium reacted, and we're told that we're looking at volume of gas formed in centimetres cubed. For this question, I would always go first of all to my moles and my equation. So begin with an equation, underneath or above include the stoichiometry, and then indicate on there any information that you have about any of the substances. We know the mass of potassium, and we know that we're looking for the volume of hydrogen. Any question always needs to begin with a calculation of a number of moles. Moles is the thing that connects everything together. Whether it's N equals CV, N equals M over M, or N times 24, all of them have N in common. So begin by finding out N. Now you don't have enough information to figure out the number of moles of hydrogen and therefore to figure out the volume. That's because you don't have any information about hydrogen. You do, however, have the information that the stoichiometry between the hydrogen and the potassium is a 1 to 2. And so what you can do is calculate the number of moles of potassium using N equals M over M. Now you can see here that I've written N for moles, and in brackets next to it, just curly brackets, I've put the substance that I'm referring to. It makes it very clear to the examiner and very clear to yourself what you are doing when you do it this way. Scribblings and numbers over a page are never a good thing. So if we use N equals M over M, where our molar mass comes from our periodic table, we end up with 6 times 10 to the minus 3 as our number of moles of potassium. Using our stoichiometry, number of moles of hydrogen to number of moles of potassium being 2 to 1, or rather 1 to 2, we know that the number of moles of hydrogen is 6 times 10 to the minus 3 divided 3 by 2, so 3 times 10 to the minus 3. We now have a number of moles of hydrogen, and once you have a number of moles of hydrogen, it's much more simple to calculate further information. If we use our V equals N times 24 or V equals N times 24,000 if we're working in centimetres cubed, we take our number of moles that we have just calculated here, 3 times 10 to the minus 3, multiply 3 by 24,000 to give us 72 centimetres cubed. Just remember to check your unit. The reason is that sometimes, sneakily here, they change what we are looking for, or they don't give you a clear indication in the question. So if you were to calculate in decimeters cubed and to state your number in decimeters cubed, you wouldn't get 3 marks, you would likely get 2. So just check what unit they're asking for.